Hello everyone. In this session, I'm going to explain about cloud formation and AWS. So let's understand a few things about a cloud formation, then move on to the demo. So what is cloud formation? So it is a service that help you model, provision and manage AWS resources in an organized and automated way. It help you to set up and manage your AWS resources easily. You can set up your resources easily. Instead of creating each resources manually, you write a simple script templates in a JSON or a YAML file describing what you need, what resources you need, what databases you need, or networks. So it's built everything for you automatically and keep it organized as a single stack. If you want to update or delete this setup later, you just change the script or remove the stack. It's like having a blueprint for your cloud infrastructure. So, why cloud formation? Why it's important and why we need? So, using cloud formation offers several advantages for managing infrastructure, especially when compared to a manual or a semi automated process. So, the first thing is infrastructure as a code. So, it's a reusable template, version control, and it's a human readable. So that's why we call it as a infrastructure as a code. Write templates in a YAML or a JSON to define your resources once and reuse them across environment. So stores templates in repositories like example Git for better versioning, tracking, and a collaboration. And YAML makes infrastructure defines easy and read and modify. So the next thing is automation and efficiency. For automation purpose, we use CloudFormation. So it's handle creating, updating or deleting resources, save time and effort for us. It's understand the relationship between resources. For example, creating an EC2 instance after VPC and a subnets are ready. Easily duplicate environment for testing and staging or production. So the next thing is consistency and reliability. So ensure all teams use the same templates and reduce the misconfigurations. Automates process to eliminate manual error in provisionings. So the next thing is simplified updates and rollbacks. Preview how proposed changes will impact for the existing resource before applying them. Automatically revert to a previous state if an update fails. The next thing is scalability. You can easily scale resources across multiple regions or accounts by running the same templates. Break complex architectures into manageable components by linking templates. So, when to use this cloud formation? So, when managing multiple AWS resources with interdependencies, to ensure consistency deployment across multiple environments, for automating resources provisioning and updates, to implement infrastructures best practices and for reduce the human errors. So how cloud formations will work? So the first thing we need to do is we need to create a template. So the first thing is we need to create a template. So here you define your AWS resources and their configuration in a CloudFormation template, that is JSON or a YAML file. For example, you can specify an EC2 instance, security groups and VPC, etc. So the next thing is you need to upload the templates. So let's go and create a template first. Then I'll show you how to upload the templates. So yes, this is the YAML file I have created to. So this CloudFormation templates creates an AWS S3 buckets with basic configuration. It uses parameters to allow dynamic input for the buckets name and set up versioning for the buckets to keep track of all the objects. So AWS template formation version. So this specifies the version of AWS CloudFormation template format value are 2010 0909, which is the most commonly used version. So the next thing is description test bucket using CloudFormation with versioning enabled. So it's provide a short description of what the CloudFormation stack will do and the value will the test bucket using CloudFormation with version enabled. So the next thing is parameters. So here allow for dynamic inputs when launching the stack. So the bucket name, the name of the S3 bucket default is, so this is the default name I'm giving. Mm, you can customize these when the deploying the stack. This you whatever the name you like, you can give the name here. So the next thing is resources. These sections contain the definition of the S3 buckets. The main bucket, I'm specify the type AWS S3 bucket. It creates the S3 buckets with the specified properties. The bucket name, the name of the bucket is set using the bucket name parameter. So the next thing is version configuration. So it's enable version on the bucket, ensuring that the previous version of the objects are retained, and the output allow you to retrieve useful information about the stack after deployment. And the main bucket name outputs the name of the created bucket. um, so this is what I'm going to create it in a cloud formation. So for now I'll comment this one. So save this. So go to your AWS account. Let's create on stack, create a new resource standard. So here, I'm using choose an existing template, and here I'm uploading a template. So choose the file that you have created. So in this I have created cloud formation. So yes, cloud formation YAML file you need to create. So upload that one. So see, it will show the URL of the S3 bucket, as well as I'll show you S3. So see, still I have not created this, but the bucket already has been created with the name. So this is the URL. Click on next. So name, and this is the bucket name. Here I'm giving the stack name. So click on create. So this thing will remain same. Click on next. So review and create. So click on submit. So see, the creating is in process. So let's wait few minutes until the buckets get created. So the process is completed, and let's go and check in the S3. Yes, the bucket has been created. So this is how the cloud formation works automatically when we specified them in the template. So um, next thing is the bucket version is disabled. I need to enable this one. So for that, I'll run this command, verify configuration, save this. So what you need to do is, once again you need to update the template, replace existing template, upload a template file, choose file, cloud formation, open. So click on next, rest of the thing will be default next. See, it will show the template URL also, the stack description. So here we have modified the bucket now. So click on submit. So the updated in progress. Let's wait few minutes. So the update has been completed, and so let's go and check whether the bucket versioning is NC. Yes, the bucket versioning has been enabled. Previous it is in a disabled state. Now it has been changed to the enable state. So this is how the cloud formation works. So I have shown how to upload the templates and provisioning the resource and stack the resources. So if you want, you can update the same template. So it will automatic rollback. So this will be the rollback content. So and it will show the output. So this is the steps how the cloud formation will works. So in cloud formation, we have a important topic called a drift. So what is drift in cloud formation? So stack action. So here you can see the detect drift. So what is mean by drift? So in AWS cloud formation, drift refers to the situation where the actual configuration of the resource in a stack diverges from the configuration defined in the cloud formation. These can happen if resources are manually modified outside of the cloud formation, or if an update to a resource was not captured by the template. How it works: drift detection does not automatically fix the drift resources. It only helps you to identify where drift has occurred. It works for the most AWS resources supported by the CloudFormation, but there may be exceptions. Drift detection can be performed at any time and is useful for maintaining, configuring, especially in a production environment. In the summary, drift detection in CloudFormation helps ensure that your resources remain in the state defined by the infrastructure as a code. Template has been tracked manually or unauthorized changes. So click on detect drift. So see drift detection initiated for the this name. So after this, view the drift result. So still not checked. It is in a INSIC mode. So refresh. So yes, it is in a INSIC mode. So why So I'll show you one thing. So here, just edit this and keep it as suspend, save changes. So now click on detect drift. Drift result. See, drift and modify. The content has been modified. So select this, view drift result. See, so the property will be version configuration status, changes not equal. They are expecting it should be enabled by, we have the current value is in a suspended state. So this is not in a equal state. So this is how the drift will work. So go to stack, go to bucket. You can manually change this for enable. Click on save changes, go to this, so click on detect drift. So let's wait few minutes and so view drift result. So yes, it is in a sync and sync mode. So view drift, so there is no differences. So before we have give a suspended, so it has been shown. Now there is no changes here, so that's why it's not showing. So this is how the drift will work. So let's understand something called which should you use choose for automation purpose, because for the automation purpose we use CloudFormation, Terraform and Ansible. Infrastructure automation, use Terraform for multi-cloud flexibilities or CloudFormation for AWS exclusive projects. So CloudFormation are used for only AWS platforms. For task and configuration automation, use Ansible to automate application deployment, updates and orchestration task. So combined approach, when that use Terraform or CloudFormation to provide provision infrastructure. For provisioning infrastructure, we can also use Terraform or CloudFormation. Use Ansible to configure and manage application on a provisional infrastructure. So this is how the cloud formations are works in a AWS. That's all about the cloud formation.